Wiring. 9 POP4 RS-232 optical isolator. The 9 POP4 RS-232 optical isolators are used between computers and microlock-2 equipment where the distance between them is less than 15 meters. The model 9 POP4 isolates and protects RS-232 equipment from lightning surges, accidental high-voltage shorts and ground loops. Normally, it is used between port 5 and maintenance PC. Wiring. Typical system configuration. The typical system configuration details the station master's room wiring, microlock-2 room wiring, and the wiring between these two rooms. In the interlocking microlock-2, port 1 and port 2 of CPU are used to transfer vital data between two CPU cards, while port 3 is used to interface with maintenance PC to monitor panel operations and train movements. Port 4 acts as a VDU panel interface. Port 5 is used to interface with maintenance PC. In a typical system configuration, the microlock-2 CPU and input-output cards are duplicated to increase the availability and mean time between the failures. The card files A1 and A2 of microlock-2 are duplicated as B1 and B2. Port 2 of CPU cards of card files A1 and A2 are interconnected. They are required to be configured as master and slave ports respectively. Port 3 of the CPU card of card file A1 is connected to maintenance PC through RS-232 optical isolator to monitor panel operations. Port 4 of the CPU card of card file A1 is connected to the RS-232 port of the VDU panel through RS-232 or RS-485 converter cum isolator connected at either ends. RS-232 port of the VDU panel acts as master, and the port 4 of card file A1 is configured as slave. Similarly, port 2 of CPU cards of card files B1 and B2 are interconnected. They are required to be configured as master and slave ports respectively. Port 3 of the CPU card of card file B1 is also connected to maintenance PC through RS-232 optical isolator. Port 4 of the CPU card of card file B1 is connected to the RS-232 port of the VDU panel through RS-232 or RS-485 converter cum isolator connected at either ends. Port 5 of CPU card of any card file is connected to the maintenance PC for debugging purpose. Since the card files A2 and B2 are provided with vital input cards and vital output cards, they are connected to the relay rack through parallel wiring. The output from the relay rack is delivered to the field via cable termination racks. Wiring. Vital cutoff relay. The vital cutoff relay, VCOR, is used by the microlock-2 system to control the power to all vital outputs. Vital cutoff relay is connected to A6 terminal of the power supply card. From A6 terminal, controlled positive voltage B12 is supplied to VCOR. Through the front contacts of VCOR, the 24 volts DC relay switching supply is connected to the output card terminals A16 and A22. Wiring and protection practices. Wiring practices. Cables. Different types of cables like power cables, serial communication cables, input cables, output cables, and panel cables are used for system wiring. Sufficient cable length for future adjustment should be provided for the equipment. Cable joints should be avoided between the terminals. Cable insulation resistance must not be less than 20 megaohms. Racks. Dust-proof metallic racks are used to protect the card file. All the racks used are insulated from the ground by means of PVC bushes or suitable mounting bases. Adequate moving space is to be maintained around the racks. Ladders. Cable ladders are installed horizontally. These are isolated from racks and walls through rubber bush and Hylam sheet. All power cables, input cables, output cables, and serial communication cables should run on different ladders. Where it is not possible to run on different ladders, power cables are to be separated from the other cables at least by 6 inches on the same ladder. Input and output wiring. The input and output wiring to a particular unit should be separated from each other and from the power wiring. All input wires, output wires, and power wires should be separately bunched together. Each of these wire bunches are routed in a separate trough or channel. Power wiring. The power supply wiring and equipment should be located close to the microlock 2 and other electronic equipment to minimize the voltage drop and induced noise. Separate power supply is required for external and internal equipment. This ensures that external surges and transients are not directly connected to the internal bus bars. Earth wires associated with main power supply should be installed. These wire lengths should be kept as short as possible and away from the signaling power supply and signaling earths. It should be of reasonable cross-sectional area to minimize the power loss. Case or house wiring will also be arranged to minimize noise. Serial link wiring. The serial data cables are used to minimize the noise due to capacitive, inductive, and radio frequency coupling. For maximum noise protection, these cables must be shielded with an overall shield and should not contain more than required twisted pair conductors. The cable shields must be earthed at one end only. All cable shields located within the CPU card 48-pin connector must be bonded together and must be attached to the microlock 2 chassis. Color coding of wires or cables. Blue or gray-sleeved shielded serial communication cable is used for serial communication wiring. 4x5 twisted pairs blue-sleeved shielded serial communication cable is used for RS-485 standard serial ports. 8-core gray-sleeved shielded serial communication cable is used for RS-232 or RS-423 standard serial ports. Red and black or blue and yellow color wires are provided for power supply wiring. 16 by 0.2 mm blue or black color twisted pair wire is provided for vital input cards. 16 by 0.2 mm gray, red and black color wires is provided for vital output cards. 16 by 0.16 mm gray or blue or red color wire is provided for non-vital input or output cards. Labeling. All cable ends should be provided with proper identification tags. All the terminals should have identification markers. All the wires connected to the terminals should have proper PVC ferrules. Column or row in the rack should be numbered. Labeling for all the major equipments used in the system or subsystem is required for easy identification. Termination. A perfect termination is airtight, therefore corrosion-free. Wires that need termination should match exactly with the size of the crimp contacts. Conductors of cables are to be correctly identified and should be connected to correct terminals. Conductors of cables must not be subjected to tension at the terminations. Wiring and protection practices. Protection practices. Power protection is much important in a signaling system. Power protection levels must be handled properly by staged protection. The staged protection refers to 3 stages of AC power protection and data line equipment protection. In AC line feeds, Stage 1 protection begins at the AC mains of power distribution panel. To protect the electronic equipment from lightning, electromagnetic impulses, transient voltages, and high surges, Class B type surge protection device is used as Stage 1 AC mains protection device. In AC feeds, Stage 2 protection is effective if sufficient isolation is provided. Stage 2 protection is generally not used. Stage 3 protection is Class C type power line protection provided at 230 volts AC input of the equipment to protect from low voltage surges. Surge suppressor is provided at 230 volts AC input of the equipment such as operator PC and maintenance PC. Data line equipment getting affected due to voltage surges and electrical transients. Sources of electrical surges like nearby lightning strike, which will affect nearby data line through induction. Electrostatic discharge is another form of an electrical surge that can affect data line equipment. In order to protect the equipment from incoming surge through data line, the following protections are to be implemented. Twisted pair wiring. A pair of twisted wires is loosely twisted at 10 twists per meter. Twisted pair wires are used to immune to noise from neighboring cables or external source. Twisted pair wiring is adopted in all vital input and vital output circuits and in RS-485 standard serial communication circuits. Isolation. Isolators block unwanted currents originating on one side from reaching the other side. It is designed to eliminate the ground loops. A ground loop is a current across the cable created by a difference in potential between two grounded points. When two devices are connected with different ground potentials, the current flows from high potential to low potential by traveling through data cable ground wire. If the voltage difference is large, one of the RS-232 port can be damaged. Small potential difference can cause data transmission errors. An isolator allows a computer to be connected to a data transmission line without risk of damage from electrical transients and also surges or spikes. Isolator and converter-cum-isolator are provided for serial communication circuits. The isolator provides 2500 volts isolation between its input and output sides and protection against lightning damages. The converter-cum-isolator provides 2000 volts AC isolation between its input and output. Non-vital input-output interface protection requirements. Generally, indoor signaling cable is used to interface control-cum-indication panel and non-vital cards, and panel room is located adjacent to the microlock 2 equipment room. If panel room is located in a different building, use underground twisted pair jelly-filled cables to interface control-cum-indication panel and non-vital cards. Also, non-vital board output line filter box are provided for all non-vital card terminations at the termination rack to protect equipment quickly and safely to avoid damage caused by transient surge voltage. These transient surge voltages are due to lightning and equipment switching. Vital input-output interface protection requirements. The vital inputs from field to the microlock 2 equipment are read through a relay contact that provides galvanic isolation. Hence, surge protection device is not required for vital inputs. The vital outputs from the microlock 2 equipment to the field are through vital relays which provide galvanic isolation. Hence, surge protection device is not required for the vital outputs since output vital relays provide galvanic isolation. Transorb or transient voltage suppressors are connected across the coils of the vital output relays act as relay coil snubs. These transorbs dissipate large electromagnetic surges caused due to de-energization of the relay coils. They prevent these surges from damaging microlock 2 system. Reduction of noise in the cable can be taken care of by using twisted cables for vital input or vital output of the termination racks. Earthing. Introduction. Earthing is preferred for the electronic equipments as it provides a low impedance path to fault currents, reduces shock hazards to personnel, provides protection from lightning, controls electrical noise levels, minimizes the system downtime as it minimizes the equipment failures, increases equipment life, joins all earthing points to achieve equipotential bonding. In conventional earthing, galvanized iron is used as an earth electrode. However, it has its own limitations as it is corrosive and requires maintenance. Requires the usual watering schedules to maintain the earth resistance within limits. Is a bolt nut mechanism. These limitations are overcome by maintenance-free earthing, which employs steel conductors called copper-clad pipes, graphitic compounds and non-corrosive salts called ground-enhancing material to avoid corrosion, exothermic welding. Thus, maintenance-free earthing is required for installations where earths are not freely accessible for maintenance and measurements. Let us now discuss the maintenance-free earthing procedure in detail. Step 1. Augering. Dig a suitable earth pit of 4 to 6 inches diameter. Step 2. Rod driving. Drive the copper-clad earth electrode into the augured hole. Step 3. Pouring earth-enhancing compound. Pour the earth-enhancing compound into the earth pit with loam soil backfilling. Earth-enhancing material is a highly conductive compound with low resistivity of 0.17 ohm meters. Step 4. Exothermic welding. Connect the copper bus bar to the electrode using exothermic welding. Connect the copper bus bar to the room earth bar mounted in the equipment room using exothermic welding. This connection requires 2 cadmium cables of 3 by 16 inches diameter. Due to lightning, a very large amount of current will be dispersed through the ground in all directions and will result in different ground potentials. To achieve equipotential bonding to protect the equipment from the damages due to different ground potentials, perimeter earthing is required. Earthing. Perimeter earthing. In perimeter earthing, earthing electrodes are required to be provided surrounding the equipment room and power room. The distance between adjacent earth pipes shall not exceed twice the driven depth. Hence, maintain the distance of less than 20 feet between 2 earth pipes. A trench of 24 inches deep and 12 inches wide is to be dug between all earth pipes to accommodate 3 by 25 mm copper strap for interconnection of successive earth pipes. The entire trench is to be covered with earth-water mix. Earth pipes installed along the perimeter of the equipment room and power room must be coupled together to form the building perimeter earth. A separate earth pipe is installed near the equipment room of the building, other than the earth pipe that forms the perimeter earth. This earth pipe forms the low-voltage earth pit, which will be connected to the star-connected equipment earth and perimeter earth. The low-voltage earth pit to room earth bar is connected with 2 by 16 mm standard insulated copper wires. Earthing. Room earth bar. The equipment room earth bar shall be a copper bus bar with the required length of 50 mm width and 6 mm thickness. The room earth bar shall be pre-drilled with a number of holes of M10 size suitable for termination of bolted cable lugs. Room earth bar shall be insulated from the building structure to avoid the circulating earth loops. Each room earth bar shall be installed against the wall with low voltage insulator spacers of height 60 mm. It should be installed as per the site convenience, but the lead length should be very less. REB should be installed at a nominal height of 0.5 meters from the ground level. All terminations on the room earth bar shall be by bolted lugs with spring washers. However, the earth leads are bolted to the lugs. A separate room earth bar is provided for equipment room and power supply room. Both the REBs should be directly connected using room earth bar bonding conductors. The bonding conductor is a bare, stranded copper wire. It runs along the wall on insulators. If the bonding conductor needs to cross the building wall, it must be isolated from the building structure to avoid circulating current. The bonding conductor shall be bolted to their respective lugs. Earthing. Earth conductors are typically those conductors that carry the surge to the main point of injection into the ground for equipotential bonding or fault protection and for lightning protection. Earth conductors come out of a building and are finally terminated in an earth pit. It is recommended that the earth conductors are of stranded insulated copper cables. The earth conductor from equipment room earth bar to the low voltage earth pit should be of small piece of 6-core cable. As the earth conductor is buried in the ground, it is protected mechanically. For diversity, it is proposed that there shall be 2 such earth conductors up to the first low voltage earth pit and then on to the nearest building perimeter earth pit. Carry the earthing, rack earthing. Each rack should be connected to the room earth bar with 10 square mm insulated copper wire. The racks should be isolated from the floor of the equipment room as well as from each other. The racks should also be isolated from the top ladders. Earthing of equipment mounted in racks. Card files and chassis of equipment mounted in a rack must be grounded via the rack. This can be done by connecting the ground stud on each card file or chassis to the rack using 4 square mm insulated copper wires. Terminate this wire on the rack frame. When no ground studs are provided on the card files or chassis, ensure good contact between the metallic mounting ears of the card files or chassis and the rack using proper mounting screws and star washers. The earth terminal of other surge protecting devices such as isolator or converters used for serial communications shall also be connected to rack frame as done in case of card file or chassis using 4 square mm insulated copper wire. Earthing. Cable shields. Shielded cables should not be exposed in a particular location. These cable shields should be grounded at one end only. This end should be at the lowest impedance point with respect to room earth bar and the end closest to the room earth bar. These cable shields should be grounded at one end only. This end should be at the lowest impedance point with respect to room earth bar and the end closest to the room earth bar. The earth resistance of low voltage earth bit should be less than 1 ohm and it should be less than 5 ohms in rocky areas. The building perimeter earth resistance should be less than 1 ohm. Earthing, electromagnetic shielding. Electromagnetic interference shielding is done as a standard practice for micro-lock 2 installation. Equipment must be shielded to protect from radiated magnetic fields. Shielding can be achieved by locating the equipment in card file with fully enclosed as possible by means of appropriate external enclosures under consideration for the equipment. EMI shielding is done by using bare copper conductor to run along the 4 walls inside the relay room, and it is placed with a proper insulated stud along the 4 walls. A 10 square mm bare stranded copper wire is used for this purpose. The spacing between the rows must be kept 75 centimeters to arrest minimum wavelength of electromagnetic interference which is being induced inside the room due to distant lightning. Copper wires of each row are fully connected to REB of the micro-lock 2 equipment room. By this, electromagnetic interference being induced in the room will be earthed. Thus, micro-lock 2 equipment is protected. Operations. Introduction. The micro-lock 2 operation can be performed either from a control-cum-indication panel or from visual display unit. Using any one of these control units, a route can be set or cancelled. Either conventional control-cum-indication panel or visual display unit will be used at any point of time, and the other console will be dynamically updated for indications only. Operations. Point operation. To set a point. Step 1. Press and hold the point button. Step 2. While still holding the point button, press the reverse point button to set to reverse route. Or, while still holding the point button, press normal point button to set to normal route. Operations. CCIP to set a route. Operations to set a route. Operations through control-cum-indication panel are similar to the conventional panel, that is pressing the signal button and the concerned route button simultaneously. For example, let us set a run-through route via down loop line. Step 1. Clear the home signal S1 to down loop with overlap to main line. Step 2. Clear the starter S3 and then clear the advanced starter S6 after taking line clear from the station in advance. When the train moves, it can be monitored on the control-cum-indication panel. Operations. CCIP to cancel a route. To cancel the set route, step 1. Press the concerned signal button and press the emergency signal button to put back the signal to on aspect. Step 2. Press and hold the signal button and press the emergency signal release button. While still holding the signal button, press the concerned down main route. The set route is now cancelled, provided there is no approach or dead approach locking. This operation is registered by the emergency full route cancellation counter. Operations. VDU to set a route. To set a route through main line using visual display unit. Step 1. click on SM key. From the context menu that appears, select the option Key In. Step 2. A pop-up window appears requesting you to enter the username and password. Enter the username and password and click OK. Step 3. Click on Panel or PC key. From the context menu that appears, select the option Request PC. Step 4. A pop-up window appears requesting you to enter the username and password. Enter the username and password and click OK. The PC indicator now blinks on the visual display unit and also on the control cum indication panel. Turn the key on the indication panel to point towards PC mode. Now, the control is passed to VDU from the panel. Step 5. Click on Signal 1. From the context menu that appears, select the option Main Signal 1 to 5, Route 1 to 5 is now selected. Step 6. Click on Signal 5 to set the route from 5 to 6. From the context menu that appears, select Main Signal 5 to 6. Route 5 to 6 is now selected. Step 7. Now click on Signal 6. From the context menu that appears, select 6 Down Starter Signal Clear. Now, the selected route is set and the signals appear accordingly. When the train moves, it can be monitored on the visual display unit. Operations. To cancel the set route through mainline using visual display unit. Step 1. Click on Signal 1. From the context menu that appears, select the option 1 Main Signal Cancel. Again click on Signal 1. From the context menu that appears, select the option 1 Main Route Release. The timer indication starts flashing for 120 seconds. After 120 seconds, the route gets cancelled. Step 2. Click on Signal 5. From the context menu that appears, select the option 5 Main Signal Cancel. Again click on Signal 5. From the context menu that appears, select the option 5 Main Route Release. The concerned route gets released. Step 3. Click on Signal 6. From the context menu that appears, select the option 6 Down Starter Signal Restore. The concerned route gets released. Maintenance. Electrostatic discharge. While working with the Microlock 2 system and in contact with the printed circuit boards, follow the below listed mandatory guidelines. Always wear a wrist strap grounding device. Connect the wrist strap grounding connector to suitable ground connection. Always handle electronic printed circuit boards by the edges. Do not touch board components. Keep the work area clean and free from dust. Once card is removed from the card file, immediately place it in a conductive, shielded bag with remarks tag. Wrap the bag in conductive foam to protect the circuit board during transportation. Maintenance. Preventive maintenance.
Do not insert or remove any Microlock 2 card with power applied to the card file. If removed, the card file or card file backplane will be damaged.
The Microlock 2 card file and all associated interface cards should be periodically inspected at least on an annual basis for signs of equipment degradation. Remove all cards from the card file. Inspect the card file backplane for loose, damaged connectors, dents, and scratches. Inspect each card for physical components damage, discolored, and insulation of wiring. Susceptible cards should be replaced. Clean the outside of the card file or enclosure using a clean, lint-free cloth. Ensure that the card file and all interface cards are properly mounted. Tighten the card retaining screws finger tight. Check all power input and signal supply leads for frayed or discolored insulation and loose connections. Check all lightning arrestor or voltage suppressor devices for any signs of physical degradation. Visually examine all wires and cables for proper bundling and slack. Remove the vital cutoff relay from the installation and inspect it physically. Maintenance. Corrective maintenance. Corrective maintenance on the Microlock 2 system is limited to the correction of basic wiring and hardware problems and the replacement of cards. Do not attempt to repair any card or peripheral device of Microlock 2 system in the field. These file components require specialized factory test equipment and procedures. Maintenance. Weekly maintenance. Measuring voltages. This is performed by signal maintainer. Note the input voltages at integrated power supply terminals and Microlock 2 rack terminals on a weekly basis. 2. Fuse checking. This is performed by signal maintainer. Fuses checking are done regularly at Microlock 2 rack and relay racks. Backup schedules. This is performed by signal engineer. The user data log, event log, and error log backup are to be taken in hard disk as well as in compact disk or digital video disk for remote storage. Maintenance. Monthly maintenance. System changeover. This is performed by signal engineer. During changeover, Siemens General Electric block instrument must be kept in train online condition. Ensure synchronization Microlock 2 clock time with maintenance PC time after changeover. 2. Measuring earth resistance value. This is performed by signal engineer. Fresh measurement value of earth resistance has to be taken. Ensure that earth resistance value is less than 1 ohms. Maintenance. Monthly maintenance. System changeover. This is performed by signal engineer. During changeover, Siemens General Electric block instrument must be kept in train online condition. Ensure synchronization Microlock 2 clock time with maintenance PC time after changeover. 2. Measuring earth resistance value. This is performed by signal engineer. Fresh measurement value of earth resistance has to be taken. Ensure that earth resistance value is less than 1 ohms. Maintenance. Annual maintenance. This is performed by signal engineer. Replace the lithium battery, if used, provided in the central processing unit card. Check the converter cum isolator used between Microlock 2 system and visual display unit panel or maintenance PC. Perform the inspection activities mentioned in preventive maintenance. Maintenance. 5 years maintenance. This is performed by signal engineer. Inspect surge protection devices once in every 5 years and replace if found deteriorated. Maintenance. System failure register. Maintain a system failure register as shown in the table above to log details of system failures and corrective action taken.
Maintenance tools. Introduction. In this session, we will learn about the maintenance tools and its selection buttons functionality. Microlock 2 system is provided with Windows-based Maintenance Tool Package. Maintenance Tool software needs to be installed on the maintenance PC, which is required to be connected to port 5 of Microlock 2 Central Processing Unit card. Let us check the data of a card file of Microlock 2. Click on the Next button to continue. To get the Maintenance Tool's main menu, double-click on the Maintenance Tool icon. This tool provides access to all the tools and control functions associated with the program. Maintenance Tools. Screen Components. The Maintenance Tool's main menu window is divided into 5 functional areas: Title Bar, Toolbar, System Status Bar, Tools Selection Area, and Taskbar. Most of the functionality of the Tools program is built into the upper section of the Maintenance Tool's main menu. The title bar contains the full name of the Tools program at the left corner and the 3 control buttons at the right-hand side. The toolbar contains 8 selection buttons that are used to configure and control the operation of the Tools program. 8 selection buttons on the toolbar are Box button, Tool button, Print button, Save button, Copy button, Back button, Split button, and Help button. The Box button in the toolbar is a drop-down menu that provides access to the Tools program and configure communication. Tools program provides the capability of communicating control function with Microlock 2 unit through a maintenance PC. The Configure Communications option of Box button enables you to individually configure the BAUD rate, bits per second, and unit addresses for the laptop, Comp1 and Comp2 ports. The Tool button is also a drop-down menu that provides access to the individual maintenance tools. Each option in this drop-down menu corresponds with a selection button in the tool selection area of the window. The Print button in the toolbar outputs selected screen data to a printer. The Save button on the toolbar saves selected data to a new or existing file. The Copy button in the toolbar copies selected data to the Windows clipboard. The Back button returns you to the Maintenance Tool's main menu. The Split button creates a duplicate Tools program window on the screen. Using this function, multiple maintenance tools can be used and viewed at the same time. The Help button provides access to the Tools program help files. Click on the Next button to continue. The System Status bar shows the current application name, the unit address, the serial port presently being used by the Tools program, and the name of the maintenance tool presently in use. The Tools selection area of the window contains 17 selection buttons. Each button activates one of the maintenance tools. The taskbar, located at the bottom of the Tools program window, provides the current date and time, as well as brief text-based messages that help the user to interact with the program. Maintenance Tools. Main Menu Tools. Maintenance tools provided in this program helps maintenance personnel to perform Microlock 2 system maintenance, configuration, and diagnostics functions. Main menu displays the selection buttons. These selection buttons are grouped into 4 main categories. They are Runtime Monitor, Historical Data, System Adjustment or Setup, and Other Tools. Maintenance Tools. Runtime Monitor. Runtime Monitor contains 4 tools such as System Information, Board Information, Free Run Variable Display, and Dynamic Bit or Variable Display that enable you to view the current status of equipment and its related systems. System Information Display is used to view the most recent occurrence of significant system events recorded in the System Adjustment Table. This display shows the current version number of the executive software and the most recent system events. The display defines the action taken in response to an event. The System Information Display lists the time and date when the following types of events last occurred: system resets, system errors, unit configuration, clearing of the system log clear, clearing of the user data log clear, time changes, and clearing of conditional power supply trips. To return to the Maintenance Tool's main menu from this display, click on the Back button on the toolbar. Click on the Next button to continue. Board Information. The Board Information tool displays current status of each enabled input or output interface cards of Microlock 2 or Serial Link. Each board type is dynamically updated. Vital serial link between Microlock A to Microlock B. This button is accessible only when Microlock is configured as hot standby. Vital communication details such as number of messages sent, messages received, and communication errors are displayed on the screen. Non-vital link between PC and Microlock A. This button displays non-vital communication details between Microlock A and Visual Display Unit panel. Click on the Next button to continue. Free Run Variable Display. Free Run Variable Display tool shows the real-time status of Microlock 2 system variables in text mode. It lists the current values for selected variables, bits and real-time list of changes. All button moves all of the listed variables to a point above the end of active symbols line. Any variables listed above this line are monitored and dynamically updated by the program. None button moves all of the listed variables to a point below the end of active symbols line. Use this option when you want to start a new list of monitored variables or when creating groups. Blue rectangle represents a selected symbol. There are a number of ways to move individual variables or blocks of variables to a point above the end of active symbols line. Double-click on a variable name. Click on a variable name and drag the selection to a point above the end of active symbols line. Click on a variable to highlight it. Next, hold down the Control key as you select additional variables that you wish to move at the same time. Finally, drag one of the highlighted variables above the end of active symbols line. Click on a variable name to highlight it as the beginning of a block. Next, hold down the Shift key as highlight another variable for the end of the range. All of the variables in between become highlighted as well. Finally, drag one of the highlighted variables above the end of active symbols line. Click on the text box next to the None button. Type in the first part of the variable name desired. The tool will find the closest match to the typed-in name. Finally, click on the variable name and drag the selection to a point above the end of active symbols line, or simply double-click on the variable name. Sorting. The variable list can be stored by ID or symbol. When Sort Symbols by Name option is selected, the variables are listed in alphabetical order. When Sort Symbols by ID option is selected, the variables are listed in numeric order. Save. The obtained variable status can be saved to a continuous log file or current buffer file by using Save button. Freeze, Resume button. Freeze button enables to stop the data for all variables from updating. This feature gives a snapshot of the variable status. After paused the display, the freeze push button changes to resume. Click on the resume button to resume the dynamic updating of the variable data. Clear. Clear button removes all of the currently displayed information from the screen and restarts the updating process. To start a new list of monitored variables, Step 1. Right-click on the already existing tab. From the menu, select Add Symbol Group option. Step 2. A new group is created beside the already existing group. Right-click on the new group to rename it appropriately. From the menu, select Rename Symbol Group option. Step 3. In the window, rename Symbol Group window, enter an appropriate name of the group. For example, let us monitor the status of the signal S1. Enter S1 and click the OK button. Step 4. Press the None button to bring all the variables below the end of active symbol line. Enter the first part of the variable name desired in the text box beside the None button. Step 5. The blue rectangle moves to the variable name which starts with the entered characters. Select the group of variables you desire to monitor using the Shift key and right-click. From the menu, select the Monitor Symbols option. Step 6. The selected variables are now moved above the end of active symbol line and the status of these selected variables is displayed. Let us now create a new list of point variables. Step 1. Right-click on the already existing tab. From the menu, select Add Symbol Group option. Step 2. A new group is created beside the already existing group. Right-click on the new group to rename it appropriately. From the menu, select Rename Symbol Group option. Step 3. In the window, rename Symbol Group window, enter an appropriate name of the group, point_11, and click the OK button. Step 4. Press the None button to bring all the variables below the end of active symbol line. Enter the first part of the variable name desired in the text box beside the None button. Step 5. The blue rectangle moves to the variable name which starts with the entered characters. Select the group of variables you desire to monitor using the Shift key and right-click. From the menu, select the Monitor Symbols option. Step 6. The selected variables are now moved above the end of active symbol line and the status of these selected variables is displayed. Group Hide and List. The created groups can also be hidden. For example, let us hide the tab S1. Right-click on the tab S1 and from the menu, select the option Hide Symbol Group. Click on the Next button to continue. To view a hidden group, right-click on any of the tabs and select the group you want to view. This feature is useful in cases where there are multiple groups. Group Delete. The created groups can also be deleted. For example, let us delete the tab S1. Right-click on the tab S1 and from the menu, select the option Delete Symbol Group. Dynamic Bit or Variable Display. Dynamic Bit or Variable Display tool enables you to view the real-time status of Microlog2 system variables. It lists the current values for selected variables, bits, and real-time list of changes. Dynamic bit or variable display represents the indications graphically in strip chart view of bit and variable changes. In the above example, the bit or variable 19WN is cleared till the 14th second and then is set for interval of 7 seconds, that is, for 15th second to 22nd second. All, none, freeze and clear buttons functionality is same as free run variable display. Maintenance tools. Historical data. Historical data tool display data which an operating microlog 2 has collected and stored. All log entries are date and time stamped. This section contains 4 tools such as User Data Log, System Event Log, System Error Log, and Merged Events Log that enable to review the logged system information in several ways. User Data Log, Step 1. The User Data Log tool records only those events that the user specifies. This log is capable of recording up to 90,000 of the most recent specified boolean changes or at least 64,000 boolean and numeric changes. When the log has reached maximum limit, the newest errors will overwrite the oldest errors, that is, first in, first out. To view the User Data Log, click on the User Data Log button on the Maintenance Tools main menu. Step 2. The Select Start or End Time for Download window allows the user to determine how much of the log to view. Now, let us look at the options available on the Select Start or End Time for Download window. No start or end time. By checking this option, we can download the entire log. Download starting at. Here, we need to enter starting date and time. Download ending at. Here, we need to enter ending date and time. The date and time format for both download starting at and download ending at fields should be in month, /date, /year, space, followed by time. Now, we will view the user data log for selected time of June 22nd, 2009, 7 a.m. to June 27th, 2009, 9 p.m. Click on the Get Log button to view the reports. Step 3. User Data Log window appears, which indicates user data is downloaded. This window displays the status of all bits in the selected period. Clear indicates that the contact is dropped and set indicates the contact is picked up.
The oldest entry always appears at the top of the list. The log will finish downloading when the most recent entry has been received. Step 4. Once the user data is downloaded, that is, up to the specified end time, clock change window appears. To save the user data log file to the maintenance PC, click on the Save button on the toolbar of User Data Log window. A Save As dialog box is displayed. Step 5. In the Save As dialog box, double-click on the Weekly Maintenance folder of My Documents. Step 6. Subfolders, User Data Log, System Event Log, and System Error Log are displayed. Double-click on the User Data Log folder. Step 7.
Rename the default file name User Data with A2_22nd June 2009 _9 p.m. where
A2 is the card file name, 22nd June 2009 is the date, 9 p.m. is the time. Saving the file in this format will help retrieving the desired log easily whenever required. Then click on the Save button. The Freeze or Resume reload, clear, and start or end time buttons at the bottom of the display control the operation of the data logger.
Click on the Next button to continue.
System Event Log. The System Event Log tool records up to 5,000 of the most recent critical errors, warnings, and events on first-in, first-out basis. It contains information on less severe conditions that can cause various unit malfunctions. Events are initially sorted in sequential order, starting with the most recent event. We can change the order in which the events are displayed by clicking on the Events, Details, and Codes column header. To revert back to sequential order, click on the Time column header.
Abort button at the bottom of the display discontinues the reloading of the system log. Reload and clear buttons functionality is same as user data log. Click on the Next button to continue.
System Error Log. The System Error Log tool records only the most recent critical system errors.
Usually, the older events that include System Error Log events are lost in System Event Logger, which is undesirable. So, the System Error Log records the last 50 critical system errors on first-in, first-out basis with respect to date and time. The user cannot clear the system error log and it retains information as long as the central processing unit board has not been powered down for more than several hours. Click on the Next button to continue.
Merged Events Log. The Merged Events Log tool enables you to view errors, warnings, and events as in the user data log, system event log, and system error log merged onto the same time axis. This log also provides graphic displays of parameters and events as specified in the user data log.
Maintenance tools.
System Adjustment or Setup. System Adjustment or Setup tool is used mainly during initial system configuration to view and modify parameters of the MicroLog2. This section also contains 4 tools such as Set Time of Take Clock, Software Upload, Reset MicroLog2, and System Configuration. Set Time of Take Clock. Set Time of Take Clock tool is used to change the MicroLog2 system onboard clock time. Set Time of Take Clock display contains 3 fields that are used to set the system's date and time. The top field shows the current MicroLog2 system time. The center field shows the date and time set from the maintenance PC. The bottom field lets you enter a specific date and time. Click on the Set Time button to set the selected time.
Maintenance tools.
System Adjustment Setup, Software Upload. Software Upload tool is used for uploading custom-designed application software program from the maintenance PC to the MicroLog2 central processing unit. Use the following procedure to upload an application program to the MicroLog2 central processing unit. Step 1. Initially, select the application software file, that is MicroLog2, from the maintenance PC to upload. Now compile the program. Press Ctrl+1 keys to compile. From the results pane, ensure that 0 errors and 0 warnings have appeared. Note that warnings are permitted, but errors are not permitted during program compilation. After compiling, MicroLog listing and MicroLog programming file type are generated from MicroLog2 file type. MicroLog programming file type is required to be uploaded in MicroLog2 system. From the results pane, note down the application image checksum value, for example, 1 TF3. Step 2. MicroLog system has to power off and keep the programming jumpers 20 and 23 of Microlog 2 Central Processing Unit Board in program position 2 to 3 to enable flash erasable programmable read-only memory for programming. Step 3. Select the Software Upload option on the Maintenance Tools main menu. The system first displays a window to remind you to adjust the programming jumpers. Click on the OK button. Step 4. The system displays the Software Upload screen. This screen prompts you to reset Microlog 2 Central Processing Unit. Now, press the Reset Push button on the Central Processing Unit Board front panel. Step 5. When the Central Processing Unit Board reset has completed, a new display appears on the screen to select the application logic file to upload. Select the required application program name, Microlog programming file type, and click on the Open button.
Step 6. While the system prepares to load the application, File Upload dialog box is displayed. In this window, required file name and checksum value, for example, 1DF3, which is same as noted after compiling the required application program, is displayed to confirm the file. Now, click on the Yes button to continue.
Step 7. The system displays Upload Confirmation dialog box with a warning to ensure that the user wishes to erase the application program and upload a new application program to the unit. Then, click on the Yes button to continue. The system continues the process of uploading the new application. The process consists of 3 main operations: erase flash memory, upload file, restart Microlog 2. Step 8. When the software upload is completed, a File Upload dialog box is displayed. Click on the OK button. The system resets itself and then displays the Maintenance Tools program main menu. Finally, move the programming jumpers of Microlog 2 Central Programming Unit card back to the locked position.
Maintenance Tools.
System Adjustment Setup, System Configuration. The System Configuration tool is used for checking and modifying the configuration of the Microlog 2 system hardware and software. To access the System Configuration options, click on the System Configuration button on Maintenance Tools main menu. The system displays Password dialog box. In this Password dialog box, we have 3 options. If we select Examining Settings option, the system will permit no changes to the displayed configuration parameters. Modifying Non-Vital Settings option lets you to modify the non-vital settings only. Modifying Vital and Non-Vital Settings option lets you to modify all settings. If you select Examining Settings option, you do not have to enter password. If you select the Modifying Non-Vital Settings or Modifying Vital and Non-Vital Settings option, password field is active, and then enter the appropriate password. The default password is Microlog II. For instance, we will select Modifying Vital and Non-Vital Settings option. Enter the password in the password field, then click on the OK button. Now, System Configuration screen appears with 3 sections, such as System Configuration, Board Configuration, and Link Configuration. System Configuration options enable you to modify the general system parameters and the user parameters and to assign specific parameters to the user data log. This section contains 4 tools such as General, Timers, User Variables, and User Log. General. There are several symbols used in the configuration displays that denote what data you can and cannot modify. The symbols are defined below. It is a fixed field with information that cannot be changed. Information is vital and cannot be left blank. You can change the information as required. Check the general system settings on this display as follows. The top 4 fields in this display show the dates on which the system, vital and non-vital configuration settings were last modified.
In Event Class Logging Thresholds field, each event listed on this display is a system event predefined in the Microlock 2 executive software. These are used to manage the amount of information placed in the event buffer during system operation. The setting indicated for each event 1, 2, 3 determines the logging level for event. Default event is 1 set at the factory itself during system configuration. The timing parameters are set in the application program. These parameters specify delay periods in milliseconds. Logic timeout delay period is used by the system during normal operation. In delay reset field, delay time after manual reset of the system is mentioned. The PC configuration fields are used to set the port address and baud rate for the Microlock 2 Central Processing Unit Board diagnostic port, that is port 5. The default settings are shown to the right of the individual fields. After you have modified the information in one or more fields, 2 buttons near the bottom of the window become active. The Apply Defaults button lets you change the data in all of the fields back to the default values as set in the application program. The Reset Changes button lets you undo all of your current changes. When general system configuration parameters have been set to the proper values, click on the Done button. A configuration dialog box will be displayed. Click on the Yes button to save the configuration changes and complete the configuration for the general system settings. Click on the Next button to continue. Timers. Timers appearing in this screen are defined in the application software as adjustable timers. The timer values are specified in milliseconds. Default values mentioned in this section against each timer are defined in the application software. These timer values can be adjusted to a required value in this timer configuration section. When the timer values are changed as required, click on the Done button. A dialog box is displayed to confirm the changes. Click on the Yes button to save the timer configuration changes. Click on the Next button to continue. User Variables. User Variable screen shows installation address, application data version, and executive software version fields. These field values are required to be filled as defined on the application software. Click on the Done button. Then Microlock 2 configuration dialog box appears on the screen to confirm the configuration changes. Now click on the Yes button to save the changes. Click on the Next button to continue. User Log. The User Log display enables the user at site to define a custom set of variables and events that are to be logged in the user log. Each parameter in the list will be logged in the user log if the associated selection box is selected. After selecting the required parameters, click on the OK button. Click on the Next button to continue. Board configuration options enable you to enable or disable and configure the individual Microlock 2 system input or output interface cards. Board configuration is provided with 16 buttons, Jumper 1 to Jumper 16, which represents 16 interface cards of Microlock 2 card file. By using these buttons, we can enable or disable the concerned interface card. For instance, we will set the Jumper 1. When Enable has been set to the proper value for the application, click on the Done button. A dialog box is displayed to confirm the changes. Click on the Yes button to save the configuration changes. Click on the Next button to continue. Link configuration options enable you to configure the Microlog2 system communication links. This section contains of two buttons such as Vital Serial Link between Microlog A to Microlog B and Non-Vital Link between PC and Microlog A. Vital Serial Link between Microlog A to Microlog B. This button is accessible only when Microlog is configured as Hot Standby. This screen shows all the parameters for the selected serial communication link. Those are already defined in the application software. We have an option to modify the parameters as necessary. Default values mentioned in this section are defined in the application software. When all of the user-defined variables have been set to the proper values for the application, click on the Done button. A dialog box is displayed to confirm the changes. Click on the Yes button to save the configuration changes. Click on the Next button to continue. Non-vital link between PC and Microlog A. This button displays non-vital communication details between Microlog 2 and Visual Display Unit panel. This screen shows all the parameters for the selected serial communication link. Those are already defined in the application software. We have an option to modify these parameters as necessary. Default values mentioned in this section are defined in the application software. When all of the user-defined variables have been set to the proper values for the application, click on the Done button. A dialog box is displayed to confirm the changes. Click on the Yes button to save the configuration changes. Click on the Next button to continue. Done with configuration. After completing system, board, and link configurations, click on the Done with configuration button to update configuration changes. Then, configuration dialog box appears. Click on the OK button to write the configuration data to the Microlog 2. Maintenance tools. Other tools. Other tools allow special diagnostic functions to be performed. This section contains 5 tools such as System Memory Dump, Program Settings, Serial Message Monitor, Save, Delimited, and Application Download. System Memory Dump. The System Memory Dump tool enables ANSALDO STS system developers and maintainers to perform specialized debugging operations when a customer encounters a software problem. This option is required to be used by the maintenance staff only when working directly with ANSALDO STS personnel. Click on the Next button to continue. Program Settings. The Program Settings tool is used to modify the way in which the system stores and displays data. These options can also change the general appearance of the screens. The Program Settings options affect the system's overall operation. Only experienced users should attempt to modify the program settings. In Program Settings dialog box, there are 4 categories of settings such as View, Symbol Files, Logic Monitor, and Advanced. View tab specifies general display screen options, and Raw Data tab displays options for user data log and error or event log. Symbol Files tab displays the local copies of the application symbols stored in electrically erasable programmable read-only memory. They are unique to each application software. All old and unused symbol files associated with old and unused application softwares should be removed periodically. Logic Monitor tab enable to set the system's polling interval in milliseconds. Polling interval represents how often the tool display is updated with information from the system. It specifies the type of free run processing time messages. Advanced tab enables to enter information onto the display in these ways. The writable data path is the location to where the symbol files are saved locally by the tool. The communication port timeout indicates how long the tool will attempt communications with the system before giving up. The communication transit delay indicates how much of a delay there should be in the transfer of each character to ensure that no character is lost. The configuration application download for microcab will only download for microcab type application files. As on date, this feature is not used for Indian Railways. Click on the next button to continue. Serial Message Monitor. The Serial Message Monitor tool enables you to monitor serial message traffic on a selected active serial link. To monitor serial message traffic, select an enabled serial link on the left-hand side to monitor the list. Click on the Start button to begin monitoring. Message traffic sent and received on the serial link will begin appearing on the right side of the serial monitor screen as it is sent or received. The display will show the approximate time the message was sent or received, the message type, and the message context in hexadecimal bytes. Similarly, to view non-vital communication between PC and microlock, select NVL PCA. The message display may be stopped for study or review by clicking on the Stop button. Clicking on the Clear button clears the display. Click on the Next button to continue. Save, Delimited. The Save, Delimited tool lets the user download the user data log in a delimited format. This file can be viewed in Microsoft Excel. The file can be saved via the diagnostic port link or directly from the PCM CIA card in the card reader on the individual PC. To save the user data log in delimited format. To download from the diagnostic port link, click on the Save from Unit button. To download from the Personal Computer Memory Card Internet Association PCM CIA card reader into PC, select Socket 1 from drop-down menu. Then click on the Save from PCM CIA button. Click on the Next button to continue. Application Download. The Application Download tool lets the user download the application image from the electrically erasable programmable read-only memory on the Microlock 2 unit. As a default, the file is stored with Microlock programming file type, so it can be easily uploaded to the system if necessary. To download the application, click on the Application Download button. A Save As dialog box is displayed. From Save As dialog box, select the appropriate file and click on the Save button. There are two progress bars on the display. The lower one shows the progress of downloading the data blocks, and the one in the center shows the progress of the file being written. As the download completes, File Download dialog box is displayed. Click on the OK button to confirm. Testing. Testing of Microlock 2 electronic interlocking system is carried out in two phases. System testing at factory premises called as Factory Acceptance Test, System Testing at Site called as Site Acceptance Test. Factory Acceptance Test. Factory Acceptance Test for Microlock 2 electronic interlocking system shall be tested in factory environment with simulation setup to validate application software. The purpose of factory acceptance test is to ensure that the Microlock 2 interlocking system fulfills the station interlocking and route control chart requirements and working in safe manner even if any false inputs or information received. Minimizes the site errors and risks and reduces the corrections at site. This results in saving of time at site testing. Factory acceptance test is carried out through simulation setup using simulator panel with toggle switches or simulator PC with Microlock interlocking simulation setup MISS software in which all field inputs are simulated. Factory acceptance test is carried out for each station interlocking separately. After designing the application software, designer issues it to the validation department for carrying the factory acceptance test. It is carried out only through visual display unit, whereas site acceptance test is carried out through control indication panel and visual display unit if both the options are available at site. Application logic is modified for the factory acceptance test. Testing for timer values used for signal, point, overlap and cancellation are reduced from 120 seconds to 12 secs to speed up the testing. It is essential that the original times are reinstated and validated at the completion of testing. In factory acceptance test setup, the input-output boards are not physically present and the same is simulated using the test setup MISS. Therefore, field inputs and outputs delivered by input and output card will be displayed and will be directly delivered into simulation visual display unit. However, this will not affect the interlocking part of the application logic. To carry out factory acceptance test, the following inputs are required: signal interlocking plan, route control chart, control indication panel diagram, cross table, Microlock 2 station interlocking application software files as designed, that is .ml2, .mll, .mlp. After carrying out factory acceptance test, the following are the outputs: Microlock 2 station interlocking application software, Microlock 2 station interlocking application software files as tested, .ml2, .mll, .mlp, ANSALDO STS Total Management System Forms, Factory Acceptance Test Certificate. For detailed testing procedure of factory acceptance test, please click on FAT Procedure. If railways or customer testing is completed, then the checksum and CRC values of the factory acceptance test simulated application logic will be recorded as per the application logic, and it is to be jointly signed by ANSALDO, STS and Railways representative. Site acceptance test. Site acceptance test defines the procedure for site testing of Microlock 2 station interlocking system where tests are executed at site environment. Site acceptance test mainly involves the system integrity and functional testing of all equipments, and interlocking testing also shall be carried out with full setup except the trackside equipments. Site acceptance test is carried out for each station separately. Results of the tests are observed and documented in a test report. The site acceptance test ensures that all equipments installed at site, that is, microlock 2, communication equipments, power supply equipments, relays and control cum indication panel are functioning correctly as per approved system configuration and station interlocking requirements and working in safe manner, and fail safe even if any equipment fails or false inputs or information received. Site acceptance test ensures the overall system safety and error-free system is being delivered to the client. To carry out site acceptance test, the following inputs are required: microlock2.ml2.mll and .mlp file, hard copy and read-only soft copy, station signal interlocking panel, station route control chart, station control cum indication panel diagram, cross tables, wiring circuits. All the equipment involved for station working is being installed before proceeding for site acceptance test. So, there is no need of separate setup is required except to simulate the field inputs with simulation panel. All the field inputs are simulated by using simulation panel through toggle switches, and inputs are sending to microlock 2 via relays, and the field outputs are sending to lamps through relays. The following testing shall be carried out while doing site acceptance test: visual test, wire count test, bell test, insulation resistance test, earthing test, power on, vital cutoff relay, communication testing, correspondence test, system integrity test, interlocking testing, changeover test. For detailed testing procedure of site acceptance test, please click on SAT Procedure. Troubleshooting. Introduction. Troubleshooting of microlock 2 must follow a logical approach that minimizes the time needed to isolate a fault or a series of related faults. To detect the faults easily, each card in the card file are provided with visual indications. The central processing unit card, power supply card, and all the input-output interface cards are provided with front panel light emitting diodes, LEDs, that help in understanding the healthiness of the cards. The central processing unit card also has two alphanumeric displays on its front panel that display the error codes. Maintenance Tools software helps to identify the fault error. It helps the maintenance personnel to restore the system by replacing the faulty card. Warning: faulty card has to be replaced, but not to be repaired at the site.
Troubleshooting.
Isolating the malfunction. This section explains a general process to be followed when isolating most microlock 2 system malfunctions. Step 1. If available, review the previous failures from the system failure. Register to define the circumstances associated with the problem, the date and time of the malfunction, the condition of the system at the time of the malfunction, the location of any trains in or near the interlocking when the malfunction occurred. Step 2. Observe the microlock 2 system indications for any clues that might lead to a quick diagnosis of the problem. Check the following: the power supply board 5 volts on LED indication should be on. The power supply board vital cutoff relay LED indication should be on. The central processing unit board on-line LED indication should be on. the Central Processing Unit Board VPP LED indication should be off. The Reset LED indication should be off. The Central Processing Unit upper 4-character display should be scrolling the phrase US and S microlog 2 followed by Executive Software Version Number. The Central Processing Unit lower 4-character display should be scrolling the station name followed by Application Software Version Number. Step 3. In addition to the system-related indications, observe the indications on all input-output cards. Step 4. Attempt to reset the microlog 2 system by pressing the Reset push button on the front panel of the Central Processing Unit card. In many cases, this will clear software-related malfunctions. Step 5. If the problem still persists after the system is reset, check the system error log and event log of maintenance tool for information related to the fault. Step 6. If the error and event logs provide no assistance in identifying the problem, replace the affected card of microlog 2 system and recheck the operation of the affected circuit. If this does not restore the system to normal operation, check the field wiring and any related interface cards for further defects. If the problem still persists, replace the Central Processing Unit card of microlog 2. Once after rectifying all the hardware faults, check the application program for possible errors. Note: card defective failures are generally due to poor power supply and improper earthing.
Troubleshooting.
Restoring the system to normal operation. The system error log and system event log contain historical information regarding the performance of a microlog 2 unit. These logs can be very useful when troubleshooting microlog 2 unit malfunctions. Information placed in these logs falls into 3 general categories: critical errors, warnings, events.
We see OR, failed. Event, vital cutoff relay, failed. Vital cutoff relay. This relay is used by the microlog 2 system to control the power of all vital outputs. This relay is energized by the conditional power supply output from the power supply card in the system card file. Corrective action. Ensure proper connection at the vital cutoff relay coil. Ensure locking of all crimps in the 48-pin connector at Central Processing Unit card and power supply board, including power supply board 250 Hz wire connection. Ensure output card, 24 volts DC fuse and wiring are okay. Troubleshooting. CPS down mode. Event. Conditional power supply down mode or no vital cutoff relay LED indication in the power supply board. Conditional power supply down mode. The microlog 2 maintenance software retains information about how often the system has reset within the recent past. The reason is to keep the system from continuously resetting in the event of a permanent failure. So, the system counts the number of resets within a short period. If more resets occur than a particular limit, the system will run with a conditional power supply down. Corrective action. To enter the reset mode from Central Processing Unit front panel, press and release the Reset push button on the Central Processing Unit card front panel. Quickly operate any one of the 4 front panel toggle switches. Hold the switch in the toggled position. Release the toggle switch that was operated in Step 2 after the Central Processing Unit card 4-character displays shows Reset menu. To access this function, toggle the menu up-down switch to the down position. Toggle the menu left-right switch to the right position. Toggle the menu left-right switch to the right position with clear or CPS shown on the CPU card displays. Toggle the action Accept Reject switch to the Accept position. This action resets the CPU software and vital cutoff relay and returns the CPU to the online mode. Troubleshooting. RAM error. Event. Random access memory error. Cause. This error appears when central processing unit data is corrupted. Corrective action. Replace central processing unit card. Troubleshooting. Troubleshooting the system kill condition. Step 1. Kill bit set by application logic. Each card file is given with a unique card file identification number in the application software. This data is stored on the EEPROM mounted on the central processing unit card connector. The initial processing of the application data will initiate the kill function, and further processing will not be possible until the appropriate values for the unique card file identification number, application data version number, and executive software version number are entered after the application program has been loaded. Microlog2 will be killed after the upload of new program. Procedure to clear kill condition is: click on the System Configuration option in the Maintenance Tools main menu. System Configuration dialog box appears. Step 2. If you select Modifying Vital and Non-Vital Settings option, Password field is active, and then enter the appropriate password. The default password is microlog II. Step 3. Click on the OK button in the System Configuration dialog box. System Configuration Reset dialog box appears. Step 4. Press the Reset Push button on the Central Processing Unit front panel and click on the OK button in the System Configuration Reset dialog box. Step 5. System Configuration Selection window appears. Click on the User Variables icon. Step 6. User Variables dialog box appears. Step 7. In User Variables dialog box, enter the following. Those are defined in the numeric section of New Application Software. Installation address. 1. Application data version. Do's and don'ts. Do's. This section will explain some of the best practices which are recommended to be followed while installing or operating the Microlog2 system. Keep the Microlog2 room free from dust using a vacuum cleaner. Finger tighten the cards after insertion and ensure they are fully tightened. Place the removed cards with a remarks tag into a conductive shielding bag. Maintain minimum 13.5 volts to 16.5 volts DC at the power supply card terminals. Maintain minimum 24 volts to 28 volts DC at the Microlog2 input or output power modules. Check Microlog2 system fuses at regular intervals. Take backup of user data log or event log or error log data files weekly. Ensure synchronization of Microlog2 clock time with maintenance PC after the system changeover. During maintenance, check the changeover of one system to the other system. After completion of diagnostics, reset the system and enable conditional power supply in UP mode. Refer to Maintenance Tools to bring the CPS to UP mode. The operation or troubleshooting of Microlog2 must be done under the supervision of trained personnel. This section explains few bad practices that may lead to system malfunction. Avoid such practices. Do not switch on radio equipment within vicinity of Microlog2 as it can affect electronic equipment. Do not reset the system using maintenance tool. CPU front panel reset push button when working as it affects the operational safety of the associated interlocking and the adjoining track circuits. Do not remove cards, Weisel cutoff relay, fuses, links and 48 and 96 pin connectors when the system is on, as it can damage circuit board or the card file backplane. Do not attempt to repair Microlog2 system cards at site directly, as it may risk the safety-related functions of the system. 6. Do not force cards into the slots during insertion, as the keying plugs may get damaged. Do not change jumper settings in CPU card and address select printed circuit boards, as that may cause card malfunction. Do not touch the board components to avoid electrostatic discharge that may damage the components of the card. Do not delete or modify application logic programs without authorization, as the system functioning may get affected. Do not alter Microlog2 system, maintenance PC, and operators' VDU settings without authorization, as the system functioning may get affected. Do not use any kind of solvents, detergents, or scratchy cleaners on the card file or internal components that may damage them. Also, do not use vacuum cleaner or blower inside the card file that may cause damage to it. Electronic interlocking system. Summary. Quick recap or summary of electronic interlocking system. Electronic interlocking system, EI system, is a microprocessor-based control system that achieves interlocking between functions through software. Electronic interlocking system occupies considerably less space, consumes less power, more reliable, easy to install and maintain, consumes negligible time in carrying out initial commissioning and changes due to yard remodeling. In a typical electronic interlocking system, the input cards read the condition of field inputs and panel inputs and send the information to the processor cards through system bus. The processor card executes these inputs according to the application software. Output cards drive the relevant relays based on the processed inputs from the processor card, and these relays operate the concerned signaling gears in the field like points and signals. To ensure safety and reliability in an electronic interlocking system, hardware and software redundancy techniques are employed. There are three approaches to the hardware redundancy design of electronics interlocking systems globally. 1. Single hardware with software redundancy. 2. Dual hardware with hardware redundancy, 2 out of 2 system. 3. Triple modular redundancy, TMR, hardware redundant, 2 out of 3 system. An electronic interlocking system consists of an interlocking logic, Microlog2, output relay rack, and control units like Control Communication Panel, CCIP, and Visual Display Unit, VDU. Microlog2. Microlog2 system is a multi-purpose monitoring and control system for line-side interlocking equipment and is manufactured by ANSALDO SDS, formerly known as Union Switch and Signals, US&S. The Microlog2 rack is a 19-inch rack equipment that consists of card file and vital cutoff relay, VCOR. Card file consists of 20 slots. Slots 1 to 15 and 20 are used to accommodate non-vital input or output, or vital input or vital output cards. Slots 16 and 17 are used to accommodate power supply card. Slots 18 and 19 are used to accommodate CPU card. The CPU card communicates with peripheral devices and consists of 4 flash EPROMs of 8 MB to store executive and application software, 2 fast static RAM, each 64 KB, to process the vital data, 4 static RAM, each 64 KB, to store events and errors, and 5 serial ports. Port 1 and Port 2 are RS-485 type and are used for microlog to microlog communication. Port 3 is RS-423, RS-232 type and is used for maintenance PC to give VDU panel indications. Port 4 is RS-232 type and is used for visual display unit. Port 5 is RS-232 type and is used as a debug port for maintenance. The power supply card is required for various board functioning. The vital output card controls the field gears. The vital input card monitors the field gear status. The non-vital input or output card monitors or controls the Control Communication Panel, CCIP. The vital cutoff relay controls the relay switching power of all vital outputs to ensure safety. Design of Microlock 2. The process of calculating the number of various cards required for a Microlock 2 system depending on the number of field gears which are obtained from approved signal interlocking plan and approved front plate drawing is called interface designing. After calculating the various cards required for an electronic interlocking system, application program is written in the form of boolean equations and is stored with a file name program.ml2. Application program is another form of interlocking circuit. Relay circuits are converted into boolean equations using various symbols. All the relays used in conventional circuits are called as bits when referred to application program. An application program is divided into different sections. A. Program title. B. Interface section. C. Boolean bit definition section. D. Timer section. E. Log bit definition section. F. Logic section. This program is uploaded to the flash EEPROM of the CPU card of the Microlock 2 unit using Maintenance Tools software. Wiring of Microlock 2. Card file consists of keying plugs, 48-pin and 96-pin connector assembly at its front and address select PCB at its rear. The purpose of the keying plug is to avoid insertion of wrong type of card in any slot, and address select PCB is used for CPU addressing. All cards are used with 48-pin connector assemblies except non-vital cards. Non-vital cards are used with 96-pin connector assemblies. These connector assemblies are used to interface with the motherboard of the card file. Dust-proof metallic racks are used to protect the card file. Cable ladders should be isolated from racks and walls through rubber bush and Hylam sheet. Standard wiring techniques should be followed while performing wiring of power cables, input or output cables, and serial communication cables. Phoenix make terminals are used in Microlock 2 wiring. Power protection levels for Microlock 2 equipment must be handled properly by staged protection. The staged protection refers to 3 stages of AC power protection and data line equipment protection. The RS-232 optical isolator protects RS-232 equipment from lightning surges, accidental high-voltage shorts, and ground loops. Earthing is preferred for the electronic equipments. Consistent earthing resistance of less than 1 ohm shall be maintained. Avoid improper earthing as it can cause damage to the cards. To achieve equipotential bonding to protect the equipment from the damages due to different ground potentials, perimeter earthing is required. The Microlock 2 can be operated from a control cum indication panel or from visual display unit. Using any one of these control units, a route can be set or cancelled. Either CCIP or VDU will be used at any point of time, and the other console will be dynamically updated for indications only. Recommended practices. Follow the mandatory guidelines to avoid electrostatic discharge while working with the Microlock 2 system and in contact with the printed circuit boards. Follow preventive maintenance measures to avoid few frequently occurring problems. Do not attempt to repair any Microlock 2 system printed circuit board or peripheral device in the field. Perform all the weekly, monthly, annual, and 5-year maintenance tasks without fail. Maintain a system failure register to log details of system failures and corrective action taken for future reference. Microlock 2 Maintenance Tools software helps maintenance personnel to perform a wide variety of system maintenance, configuration, and diagnostics functions. Maintenance Tools software provide access to all the tools and control functions associated with the program. Main menu selection buttons are categories into Runtime Monitor, Historical Data, System Adjustment or Setup, and other tools. Each card in the Microlock 2 rack is provided with visual indications that help detect the fault easily. These front panel LEDs help in understanding the healthiness of the cards. Maintenance Tools software also helps to identify the errors. The system error and system event logs can be very useful when troubleshooting Microlock 2 unit malfunctions. Card defective failures are generally due to poor power supply and improper the form of interlocking circuit. The different inputs required for the design of application program design, conversion of relay circuit to equation. In electronic interlocking, intermediate relays used to operate output relays are replaced with application program. The conventional relay circuits are converted into equations using various symbols. We will now see a few examples to learn the process of converting relay circuits to Boolean expressions using these symbols. Example 1. From the circuit, we observe that the output S1HR is a vital bit. Hence, the Boolean expression should start with a sign statement. In the circuit shown, S1HR1 and S1HR2 are in series to each other. Hence, use a series symbol in the Boolean expression. This logic is required to activate the output relay S1HR. Terminate the Boolean expression with the end of statement symbol. Thus, the logic would translate to. Let us now look into another example. Example 2. From the circuit, we observe that the output XYZ is a vital bit. Hence, the Boolean expression should start with a sign statement. In the circuit shown, A and B are in series to each other. Hence, use a series symbol in the Boolean expression. B is in series with the rest of the circuit. Hence, use a series symbol in the Boolean expression. There is a start of parallel path from C. Hence, use the start of parallel path symbol in the Boolean expression. From the circuit, we infer there is relay C with back contact. Hence, use a back contact symbol before C in the Boolean expression. The relays C and D are in series with each other. Hence, use the series symbol in the Boolean expression. From the circuit, we infer that the relay E is in parallel with the C and D relays. Hence, use the parallel symbol in the Boolean expression. In the parallel path, the relay F is in series to relay E. Hence, use the series symbol in the Boolean expression. The parallel path ends here. Hence, use end of parallel path symbol in the Boolean expression. This logic is required to activate the vital output relay XYZ. Terminate the Boolean expression with the end of statement symbol. Thus, the above circuit would translate to the Boolean expression. Let us now look into another example. Example 3. From the circuit, we observe that the outputs are non-vital bits. Hence, the Boolean expression should start with NV.assign statement. In the circuit shown, 18ATR is in series with the rest of the circuit. Hence, use a series symbol after 18ATR. There is a start of parallel path from here. Hence, in the Boolean expression, use the start of parallel path symbol. From the circuit, we infer that 18NWKR and 18RWKR are in series to each other. Hence, use series symbol in the Boolean expression. In the circuit, 18RWKR has a back contact. Hence, use the back contact symbol before 18RWKR in the Boolean expression. In this circuit, 18NWKR and 18RWKR are in parallel with 18NWKR, 18NWR1 and flash. Hence, use the parallel symbol in the Boolean expression. From the circuit, we infer that 18NWKR in the parallel path has a back contact. Hence, use the back contact symbol before 18NWKR in the Boolean expression. Since 18NWKR, 8NWR1 and flash are in series to each other, use series symbol in the Boolean expression. This parallel path ends here. Hence, use end of parallel path symbol in the Boolean expression. This logic is required to activate the non-vital outputs 18 NWKW, CO18 ANWKW. Terminate the Boolean expression with the end of statement symbol. Thus, the above circuit would translate to the Boolean expression. Let us now look into another example. Example 4. From the circuit, we observe that the output is a vital bit. Hence, the Boolean expression should start with a sign statement. From the circuit, we observe that there is a start of parallel path. Hence, use start of parallel path symbol in the Boolean expression. 19 BTR, UMTR, and S30 ASR are in parallel to each other. Hence, use the parallel symbol in the Boolean expression. This parallel path ends here. Hence, use end of parallel path symbol in the Boolean expression. From this circuit, we observe that 19 BTR is in series with S26 OVJ SLR. Hence, use a series symbol in the Boolean expression. There is a start of another parallel path. Hence, use start of parallel path symbol in the Boolean expression. S26 OVJ SLR has a back contact. Hence, use the back contact symbol before S26 OVJ SLR in the Boolean expression. S26 OVJ SLR, S26 OVSR, and S26 underscore 27 OVNJPR are in series. Hence, use series symbol in the Boolean expression. S26 underscore 27 OVNJPR has a back contact. Hence, use the back contact symbol before S26 underscore 27 OVNJPR in the Boolean expression. S26 OVJ SLR, S26 OVSR, S26 underscore 27 OVNJPR are in parallel with S26 OVT SR. Hence, use the parallel symbol in the Boolean expression. This parallel path ends here. Hence, use end of parallel path symbol in the Boolean expression. This logic is required to activate the vital output S26 OVT SR. Terminate the Boolean expression with the end of statement symbol. Thus, the above circuit would translate to the Boolean expression. This method is followed for all relay circuits. An application program is built based on these equations. Electronic interlocking system. Reference material. For more details on electronic interlocking system, refer to the links given in this section. Troubleshooting. Troubleshooting the general failure condition. System configuration mode failed. Event. System configuration mode failed. Cause. System settings could not be changed through maintenance tool. Corrective action. Ensure locking of all crimps in the electrically erasable programmable read-only memory PCB. Replace EEPROM PCB. Maintenance tool software is to be reinstalled. Event. Diagnostic mode failed. Cause. Bad link between Microlog 2 and maintenance PC. Corrective action. Check port address and baud bits per second rate settings in the maintenance tool. Remove and reconnect 9-pin RS-232 connector at both Microlog 2 and maintenance PC ends. Close and restart maintenance tool program afresh. Bit fail in vital output or vital input or non-vital input or output board. Corrective action. Ensure that the board is fully finger-tightened. Check the Phoenix terminals for input or output connections. Ensure locking of all crimps in the 48-pin connector and 96-pin connector. Replace the faulty board. Non-vital serial link failed. Cause: disconnection in central processing unit card 48-pin connector assembly. Ensure all the crimps are locked. Cause: disconnection in microlock 2 rack serial communication terminals. Corrective action. Tighten the terminals. Cause: disconnection in isolator or converter terminals between microlock 2 and operator's VDU microlock 2 and maintenance PC. Corrective action. Tighten the terminals. Check the isolator, 12 volts direct current. Check or replace isolator and converter. Cause: error due to noise in the communication. Corrective action. Check 12 volts DC supply of converter at the operator's visual design unit end. Cause: serial port failure in microlock 2 central processing unit card. Communication port failure in operator or maintenance PC. Corrective action. Replace the microlock 2 central processing unit card. Replace the operator maintenance PC.